167, and that is x squared plus 6x minus 5 equals 0. Okay, middle coefficient, please. Middle coefficient is? Good. Divided by 2 is? Squared is?
9.
That's it. So x squared plus 6x, I have to make room for it in here. But of course on the other side as well. And at the same time I'll move 5. 5 plus 9. To cut back a little bit on writing. It's all done. Just tell me what this is. And it's completed.
X plus 3.
Very good. That's why, as I said, I know I repeat myself a lot. My apologies. I sound like a broken record. That's why I wanted you to do the factoring so we have everyone answering this. So x plus 3, we know it should be the absolute value. Instead, we write plus or minus, equals. Plus or minus the square root of 14. We should not separate them in writing, but again, MyLab Math will ask you to separate them. And that's the method of completing the square. Let's review. Middle coefficient divided by 2, square that number, add that number to both sides. If you only add it to one side, you change the problem and you're not getting the solution. You always have to add to both sides or subtract from both sides or multiply both sides or divide both sides. If I choose to add 9 here, I have to add it to the other side. The last method, I think I'm on page 4. Last method is quadratic formula. Only if the equation is presented like this. 0 on this side, and everything, all terms in descending order on the other. Otherwise, we cannot use the quadratic formula. And the quadratic formula is negative b, this is the b, plus or minus the square root of b squared minus 4ac over 2a. This, not the square root, just this piece, has a name. It's called discriminant. I don't have enough room. Sorry about that. Discriminant. We're going to talk about it in a moment. So let's look at an example. I'm copying from what I printed out from the book. Let's say 68. On page 167, and we have x squared plus 5x plus 2 equals 0. Is it arranged correctly? Yes. X squared, where the leading coefficient is how much?
1.
Excellent. 5x, where b, or the middle coefficient, is how much?
5.
Very good. And c is the so-called free term, free of variables, free. The free term is 2. I have another laptop here that is, a tablet that is in the way. Okay, so since it's arranged correctly, I can directly start negative b, plus or minus the square root of b squared minus from the formula, 4 from the formula, a, which is 1, I'm not going to write it, times 2, which is c, over 2 times a, which is 2. So x equals negative 5 plus or minus 25 minus 8 divided by 2. A note, please do not attempt to separate like this. This is incorrect. You can separate if it's a product. You can separate if it's a ratio. The radical is a product of radicals. The radical is a ratio of radicals. But you can never separate if it's a sum or a difference. So please remember this will be incorrect. So the only thing I can do is say 25 minus 8 is 17. So x equals -5 plus or minus the square root of 17 divided by 2. There is no need to separate. My lab math will ask you to separate because they don't have the symbol of plus or minus. So you will write -5 plus over 2, comma, -5 minus over 2.
Can you show us an example where you actually divide by 2?
You mean simplify this and...
Yes.
Yes, of course. I don't know which one will be exactly like that real quick, but we'll try to find one. I have to make one up and it will take a while. So let's see, I don't know, maybe 73. It's a very good, no. I just, I was not prepared with an example like that. Maybe we do hit one quickly.
Yeah. I only asked because I need to brush up on my dividing the square roots.
Okay, so dividing square roots. But this is not a division of square roots. You're not going to have a square root in the denominator.
I know, but never mind.
Do you have an example in mind? That would be the easiest.
I don't. I wasn't thinking about it, and I just realized that if it was possible, then it wouldn't. I don't know. My brain's a little
So you are thinking of an example like the square root of 40 divided by the square root of 16 or something like that, or?
No, I meant like if you were dividing a square root by 2 or by just a regular number.
So if you have a square root of, it's a very good question. So let's do something like this. And then we'll look at another example anyway. Is that what you had in mind?
Yes.
Oh, excellent. So the square root of 20, 20 is not a perfect square, so the square root of 20 has to be simplified. So I will write the square root of 20 as, 4 multiplied by 5. And that is the square root of 4 multiplied by the square root of 5. Now, the square root of 4 is 2, and the square root of 5 has to stay as is. When I go back here and I write 2 the square root of 5 over 2, now I can simplify by 2. 1 and 1, and the final answer is the square root of 5. Is that something
Yes, that's
close?
perfect. Thank you.
Okay, excellent. It's an excellent question because we're going to get to something like that, but I wasn't sure what you meant. So let's look at another quadratic formula. Let's say 72 on 167. And we have x squared minus 2x plus 17 equals 0. Already set up as we wanted it to be. It is in descending order. I have 0 on this side. Everything is fine. A is 1. B is -2. C equals 17. Are we okay with this so far? So I can already start the quadratic formula. Negative b is +2 plus or minus the square root of. If you ever write minus here, that is a terrible error. Ever. Because this is b squared, no matter what b is. Positive or negative, we don't care. This has to be a positive number. So the beginning under the square root can never have a negative, ever. Minus. So this was b squared minus 4 times a, I'm not going to write it, times c, which is 17, divided by 2 times a, which is 2. At this point, I have x equals 2 plus or minus. I would have factored and done that differently, but let's say I'm just going to calculate it with the graphing calculator. So I have 4 and minus 4 times 17, and the answer is negative 64. So negative 64, I did not apply the square root yet, and divided by 2. Let's take this on the side. Negative 64 is the same as we discussed with negative 1 times the square root of 64, because we know that this is not real. Well, the square root of negative 1, we know this is I. We know that the square root of 64 is 8, so I'm going to write 8i. So x equals 2 plus or minus 8i divided by 2. This will be a terrible mistake, to simplify this or simplify this. That's never allowed. We never simplify terms or pieces of terms. So one option here is to write x equals 2 over 2. Separate into two fractions. Plus or minus 8i over 2 and simplify. 2 divided by 2 is 1. 8 over 2 is 4, plus or minus 4i. And that's final. Here's a second option, whichever you prefer. 2 and 8 have a common factor of 2. The denominator is 2. 2, I took a 2 out, so there is a 1 left. I copy plus or minus. 2 times what is 8i? Well, obviously is 4i. Let's check. 2 times 1 is 2. 2 times 4i is 8i. Now I am allowed to simplify because we simplify only factors. Simplify only factors. Comma, never terms. Terms are quantities that are added or subtracted. Factors are quantities that are multiplied. Terms are quantities that are added or subtracted. Factors are quantities that are multiplied. So when I simplify, the final answer is still this. 1 plus or minus 4i. So two options. Separate the fraction into two fractions, or factor out 2 from the top. Any questions on quadratic formula? Okay, so finally I'd like us to write a little note and then finish up a quiz. Here is the note. When, no, that's not good. When do I use which method? Because I know Jonathan will ask me that. He did already last time. When do I use which method? And he's right. Okay, factoring. When it takes a blink. If I'm forced to use a particular method, then it's clear. I don't have to choose. I am told. They chose that for me. Factoring when it takes a blink. If it takes me 5 minutes to factor, forget it. I don't want it. So when it takes a blink. Factoring is not always applicable. Remember, not all polynomials are factorable. So this is applicable in certain situations, not always. Not all polynomials are factorable. And I will apply it unless the method is indicated to me. I will apply it only if it takes a blink, quote unquote. Completing the square. Never. It has a different usage. If you force me to, I have no choice. If you choose for me, complete the square, then it is what it is. However, it always works. It is always applicable. Cumbersome, long, whatever you want to call it, but it's always applicable. This one is not. Taking square roots. Only in one specific situation. One situation. When I have something like this, equals a number. Not with x, no x here. Just one number, plain simple number. Here I can have whatever you want. One variable only, of course. Okay? So taking square roots is not always applicable, because I have to complete the square first. It's only in one particular situation. This one. Finally, quadratic formula. Always applicable. It's my decision. Up to me when to use it, if I want to use it. So, bottom line, if the problem is like this, only this. If the problem looks anything else, I try factoring first, if not here. This, never ever. But we need to know the method though for something else. Okay.